So here we've got a question where we've got the graph of y equals x squared minus 6x plus 12, and we're asked what is the tangent to the curve at the point 2, 4. So the tangent to the curve at a point is a straight line that just touches the curve at that point. It just intersects it once at that point. So if we put on our point here, 2, 4, that is just going to be just about here. And now we're going to draw a straight line that just touches the curve at that point. So that would look something like this. That would be the tangent line to the curve at the point x equals 2, y equals 4. So now we need to look at how we're going to find the equation of this tangent line. And what you need to remember is that the gradient of this tangent at that point is equal to the gradient of the curve at that point. So we can find the gradient of the curve at that point by differentiating and then substituting in the value of x at that point. So when we differentiate, we get dy dx equals 2x minus 6. And now we need to substitute in x equals 2, and x equals 2, our derivative, our gradient function, is 2 times 2 minus 6, which is 4 minus 6, which is negative 2. So therefore, the gradient of the tangent is equal to negative 2. So we know the gradient of the tangent, and we know a point that it passes through, this point 2, 4. So we can use our construction formula for the equation of a straight line. The gradient times x minus our x coordinate 2 equals y minus our y coordinate 4. And if we just tidy this up a little bit, we get minus 2x plus 4 equals y minus 4. And rearranging this, we get y equals minus 2x plus 8. So this is our equation of the tangent, y equals minus 2x plus 8, the equation of the tangent to the curve at the point 2, 4. Okay, so here we've got a quartic curve, y equals 6x to the power 4 minus 3x, and we're asked to find the normal to the curve at the point 1, 3. So if I just mark in this point 1, 3, that is somewhere there. And we know from before the tangent to the curve at that point is the straight line that just touches the curve at that point, which looks something like that. I'm aware it's not the best drawing ever. We're asked to find the normal to the curve. So the normal to the curve is a line that is perpendicular to the tangent at that point. So the normal to the curve at this point here would look something like this here, and it would make a right angle with the tangent to the curve at that point. So we can use a similar method as we used to find the equation of the tangent. First, we're going to differentiate to get our gradient function. So 6x to the 4 minus 3x, that differentiates to give us 24x to the power 3 minus 3. So when x is equal to 1, our gradient function is going to be equal to 24 minus 3, which is 21. So we know the gradient of the tangent at that point is 21, and because the normal is perpendicular to it, we can now find the gradient of the normal. So the gradient of the normal is going to be the negative reciprocal of the gradient of the tangent. So it's going to be negative 1 over 21. So now we can use our equation, our formula for finding the equation of a straight line. We've got the gradient, and we've got a coordinate 1, 3. So it's going to be negative 1 over 21 x minus 1, y minus 3. And tidying this up, we're going to have negative x plus 1 equals 21y minus 63. So we're going to have 21y equals negative x plus 64, y equals negative 1 over 21x plus 64 over 21. And this is our equation of the normal to the curve y equals 6x to the power 4 minus 3x at the point 1, 3.